Good morning, friends. Let's complete the follow-up 3 for this problem on stack, which is implement a concurrent stack in Java using SAS operation. SAS is compare and swap, and this is achieved in Java using atomic classes. And this solution is based on the driver stack algorithm. So let's first of all see that what is a SAS operation. So in the Wikipedia, in computer science, we can see that compare and swap is an atomic instruction used in multi-threading to achieve synchronization. It compares the contents of a memory location with a given value, and only if they are same, modifies the content of that memory location to a given value. And this is done as a single atomic operation. So, for example, if there's a pointer, let's go to the pseudocode here. For example, we have got a pointer which is pointing to a number as old, and there's a thread which wants to update it to a new value. So what it will this algorithm says is that only if the pointer is pointing to old until we are going to update it with the new. If there's any other thread which has updated this pointer to another value, it means that it is not pointing to old anymore. That's why it will, in that case, it will check this and return false. Only if this pointer is still pointing to the same variable, which for this thread, it was pointing to old, only then it will be updated to the new. And this is all done as a single atomic operation. This is a very important thing. So this is actually compare and swap and compare and set. These are like very low level CPU level instructions. So, and this is which is always held in a single atomic operation. Now let's go to this tribal stack algorithm that we are talking. The tribal stack algorithm is a scalable lock-free stack utilizing the fine-grained concurrency primitive compare and swap, as we just discussed. The basic principle of the algorithm is to only add something new to the stack once you know the item you are trying to add is the only thing that has been added since you begin the operation. It is very much similar to what we just discussed. If the thread which is trying to update this pointer to which is pointing to an old value to the new value, we need to ensure that by the time it reaches to update it, the pointer is still pointing to the same old variable. If any other thread has updated this pointer to any other variable other than old, then this operation will fail. The same thing is happening here. So in the stack, so let's go here again. Pushing an item to the stack is done by first taking the top of the stack, which is the old head. So the thread has got this top of the stack, which is the top is a pointer here, and placing it after your new item to create a new head. So whenever we know that when we push an item to a stack, so we update the top to the new element, and the new element, next element is the old head. So similarly for this compare and swap operation in this tribal stack algorithm, it will check that once we are updating this top of the old head to the new head with the new value, the top is still pointing to the old head. If any other thread has added to this stack, then the old head would have been already updated. It will not point to the same top which the current thread is holding. So this is all about this algorithm. So once we implement the code in Java, then it will be more evident that what this stack algorithm does. So let's go to our IntelliJ. I've already created a class myStack using SAS. So let's start writing the code on it. So I'll just use T, and we have to implement StackI. Yes, StackI with T. Okay. And because we have got 3 methods to implement, so I will just use the basic one. Okay. So now let's start implementing the code. Now, as discussed before, that in Java, we want to use SAS, we have to use atomic classes, which is present in Java API. So let's use the same. Here I will use atomic reference. So private final atomic reference, and I will take the stack node here. Okay, stack node, and this is mentioned as top. So new atomic reference. Okay. If you remember the stack node that we created, the stack node class is this one, in which it's a very much like a linked list data structure, in which each stack node is having an element of data, T type of data, and the next one is the node which is pointing just next to it, which is the bottom of it. So what it means is that suppose I create this stack node, right? So the data would be D here because I'm taking a string here, for example, and the next would be the one which is bottom to it, which is C. So this is what this stack node represents, and we have got the constructors and getters and setters here. Okay, so let's go back here. So here what we are doing is that we are creating an atomic reference to use the SAS operation, and we are maintaining this top variable, which is actually a stack node. So this top variable is here is this one, which we are referring to here. Now let's implement the pop method first. Or maybe let me do push first, because then it would be easier to explain this tribal stack algorithm, because it actually explains here by pushing an item to the stack. Okay, so again revise this. Pushing an item to the stack is done by first taking the top of the stack and placing it after your new item to create a new thread.